Optimal cutting of Fluxtrol material from blank stock. As shown in Chapter 5, for the majority of applications, permeability values above 30 to 50 do not change the controller performance. Main reasons for optimal material orientation is control of the concentrator temperature, which depends on losses, heat removal conditions, and duty cycle. Material orientation is mostly essential for heavy loaded applications, such as scanning or single short hardening, when concentrator losses are removing continuously by heat transfer to the copper in the process of heating. For these cases, orientation best is strongly recommended, with orientation N1 as a second choice. It is because the highest value of thermal conductivity is more important than slightly higher magnetic losses in the poles. For short heating cycles, such as contour gear hardening, orientation N2 is the second choice after best, because of lower losses in the poles than in the case N1 and lower influence of thermal conductivity on concentrator temperature. Electrical resistivity and resistance. Resistivity strongly depends on material type. It is higher in direction of pressing. It can drop after long-term exposure to temperature above 250 degrees Celsius. Resistivity is not a major material performance parameter. Only a level of resistivity should be controlled. HF materials require higher resistivity to withstand higher voltages induced inside the concentrator or applied to it. Fluxtrol A is a unique material, which has high permeability and internal electrical resistivity, but it can form conductive surface layers when machined. Touch resistance of machined parts. Machining may cause particle smearing on the surface and lead to formation of a conductive layer. Resistance of this layer may depend on material type, machining method, such as grinding, milling, saw cutting, etc., and on machining direction. Ferrotron 559H has very high touch resistance and does not form a conductive surface layer. No etching is required for this material, except in cases when we expect relatively high voltage being applied to material, such as several hundred volts. Fluxtrol 50 has good touch resistance, up to 30 ohms, on broken and machined surfaces, but forms a thin conductive layer on side-pressed surfaces. Etching is recommended for high-frequency applications. Fluxtrol A has very high internal resistivity, but can easily form a conductive layer when machined. Machining of surfaces A and B causes much less conductive layers, if any, than of side surface C, where touch resistance may be as low as 10 to 30 ohms. Etching is recommended in this case.